Dear students, today we will be discussing about calibration of ammeter, voltmeter and wattmeter using potentiometers. So first we will discuss regarding calibration of voltmeter using potentiometer. So for this, V is a voltmeter which is to be calibrated, which is being placed here, and we have a potentiometer also connected from the voltage ratio box. This voltage ratio box is very similar to a transformer, but this is used in a DC system. Here the voltage is being reduced from a higher level to a lower level, which can be given to the potentiometer. Since the potentiometer is rated for very low voltages, so you can use this voltage ratio box to step down the voltage levels or reduce the voltage levels from the normal value to the lower values, which could be easily measured by the potentiometer. You have to use a stabilized DC supply in order to get accurate results. So you have a constant or stabilized DC supply, and you are given sine and cos adjustments in the circuit. This given in such a way that this can be adjusted, and the voltage measured or indicated by the voltmeter can be or the pointer can be adjusted to one of the main divisions, so that could be read easily. And once we make the adjustments at the sine and cos levels and you get a particular reading, then you move towards a potentiometer to measure the voltage that is being measured at this particular point. So you can see that the voltage that is indicated by the voltmeter will be across these 2 points, and also the same voltage is being measured after reducing the levels. So the potentiometer will be giving the true value. So voltage measured by the potentiometer will be the true value, and the voltage indicated by the voltmeter will be the measured value. So you will compare this, and you can get the errors if the true value is deviating from the measured value. You can say that there will be some errors, or there can be some errors in the voltmeter reading, and such errors could be found out, and calibration curve can be plotted, and ultimately you can say that the voltmeter is being calibrated with respect to the standard potentiometer. So that is the process that we do while calibrating the voltmeter using the potentiometer. Now coming to the calibration of ammeter, here also we are making use of a stabilized DC source, and we also have the adjustments provided in the by means of cos as well as sine adjustments. Here we make use of a standard resistance S. The value of the standard resistance is known, and once you know the value of standard resistance, the voltage across the standard resistance is measured by the potentiometer. Now once we give the supply, some current I will be flowing through this, and this current I is being measured by the ammeter. So the current measured by the ammeter will be the measured value, and across a standard resistance you will be getting a voltage. So the voltage will be given by I into S, or this is again IA into S, and this voltage will be measured by the potentiometer. Now the voltage measured by the potentiometer will be a standard one. So so once you get the voltage measured by the potentiometer, so this could be taken like I into S. Now the voltage measured by the potentiometer will be a standard one. So once you know the voltage, you can calculate the current, the true value of current as voltage measured by the potentiometer. So this is voltage measured by the potentiometer divided by the standard resistance. Now once you get that, we can easily compare between the measured value and the true value. If it is not equal, then you can get a calibration curve, and once you get the calibration curve, you can find out how much errors are there in the measured value of the ammeter. Thus the ammeter can be calibrated against the potentiometer. Next we will move on to the calibration of wattmeter using potentiometer. Now here you can see that this is a wattmeter that is being used, and here you have the current coil as well as the pressure coil. Now the arrangement is given in such a way that the current coil is being energized from a separate low voltage supply, and the pressure coil is being energized from a high voltage supply or a normal voltage supply. Now why do we make such an arrangement? Such an arrangement is generally known as phantom loading. Okay, so this type of loading is known as phantom loading, where the current coil is being energized from a lower voltage supply. You know that very small, systems is very small, systems is very small, systems is very small. So even if you energize your current coil circuit with a low resistor, low voltage supply, you are able to get rated current even with the low voltage supply. So that's why, in order to reduce the power consumption, during measurement, we make use of such an arrangement. So again, a regulating rheostat is provided to adjust the current through this particular current coil. Now ammeter measures this particular current, and a standard resistance is again provided at this particular circuit, in this particular low voltage circuit, and this voltage across the standard resistance is being measured by the potentiometer, and it gives a true reading of the current that is flowing in this particular circuit, and current can be measured from using an ammeter also. Now a different normal voltage or a high voltage supply is also provided to the pressure coil circuit. Now a voltmeter is provided at this particular across this supply, and wattmeter is pressure coil is energized from this high voltage supply, and this particular voltage, input voltage, or the voltage that is being measured, is provided to the voltage ratio box, just as we have done in the case of a voltmeter calibration, and this output is provided to the potentiometer. So here we have a DP/DT switch, that is double pole double throw. The purpose of the switch is to switch over to the two circuits, that is the low voltage circuit as well as the high voltage circuit. So if you are switching to low voltage circuit, the potentiometer will be connected across a standard resistor, where it will be giving a voltage value corresponding to the current that is flowing in this particular current coil. And if you are switching on to this second section, so if you are switching on to this side, what you will get is that the potentiometer will be connected to the voltage ratio box, and the voltage ratio box will be indicating the voltage that is being provided from the high voltage supply. So it will be giving a reading corresponding to this particular voltmeter. So ultimately you will be getting a true reading of the current related to the low voltage supply and the true reading of the voltage. So this gives the power that is being consumed, or the power that is being true value of the power that is being given by the potentiometer, and the actual value of the power that is consumed can be obtained from the wattmeter reading as well as from the values of current and voltage. So current and voltage, when you multiply the values of current and voltage, you will be getting a value. So that will be Vm into Im. So that is measured. Again, you will be directly getting the value of power from the wattmeter also. So that also can be done. So again, you compare all these values and you can draw a calibration curve, and once you get the calibration curve, you can say that how much errors are there in the wattmeter, and thus the wattmeter can be calibrated against the standard potentiometer which is available. So this is how we calibrate ammeter, voltmeter as well as wattmeter against a potentiometer. Thank you so much.